Figure 20.15, Vector Class Template Element Manipulation Functions. In this example, we continue looking at the vector class template and some of its capabilities. In addition, we're going to start to show you some of the power of combining algorithms provided by the standard template library with iterators and containers. And in particular, in this example, we're going to show you a single line of code that's capable of walking through an entire vector and outputting all of its elements separated by spaces. So let's take a look at the example, and you'll notice that I've included several header files here. The vector header, of course, gives me access to the vector class template. The algorithm header gives me access to many of the standard template library algorithm functions, one of which is the copy function. The iterator header gives me access to various iterator capabilities, such as the OStream iterator that we demonstrated in the first code example of this lesson. And then the std_accept header file gives me access to one of the standard, or several of the standard library exception classes, one of which is the out-of-range exception class. And for the first time here, we'll demonstrate how to catch an out-of-range exception. Now, in this example, we did not provide any using declarations following these header files, and that is because in the example we're going to fully qualify each of the names that we're using from those headers. Now, I've already executed this example so that we can compare the outputs that you see here on the screen to the code as we're going through. So let's start in main with our constant integer called size, which has the value 6, and that is going to represent the size of an array. And here's the array being declared at line 16. It's an array of integers with the values from 1 through 6 in the array. Now, the next thing that we're doing here at line 17 is demonstrating a version of the vector constructor that allows you to initialize the vector with the contents of some other data structure. And basically, we need input iterators that allow us to walk through the data structure and process the elements within that other data structure so we can copy their values into the integers vector. Now, it turns out that you can also use regular pointers like iterators. So if I have an array of integers, I can use a pointer into that array to represent an iterator, if you will, to the first element. And then separately, I can use a 1 past the end iterator to say I would like to copy a range of elements from that array into my vector. So here I'm supplying the name of the array as an iterator that points to the first element of the array as a pointer or iterator. It's semantically the same thing here. And I'm using the value array plus size to indicate the 1 past the end location. And what this says is to copy the elements from that starting position of the array up until I go 1 past the end, at which point I should stop copying. And this is going to copy the full set of elements from the array called array into the vector called integers. If I only wanted the first 3 elements of the array, I could say array plus 3 here, and that would give me the values 1, 2, and 3 being copied into the underlying vector. Now at line 18, we're going to create an OStream iterator for integers, and this one's a little bit different from the previous example of OStream iterators in that when we create the output stream iterator called output, we will be outputting to the standard output stream, but every single item we output will be followed by a space character. And this is the delimiter string that is going to be inserted into the output stream automatically for every item that I say to output. And we'll see how we use that in just a moment. So at line 20 here, in fact we'll see how we use it right now. At line 20 we say vector integers contains, and here is a very powerful line of code. In one statement now we are able to say output a range of elements from the vector called integers to this output iterator that we defined back on line 18. Now the range that we're dealing with is from the beginning of the vector integers to the end of the vector, and of course again the end represents the one past the end location. When you're dealing with many of the algorithms in the standard template library, many of them use this kind of one past the end style of processing. So you give the starting point and you give one past the end point, and that helps the algorithm understand when to stop processing. So this is basically saying iterate through the entire collection of values in the integers vector, outputting them, copying them one at a time to this iterator location. And because this iterator is a standard output stream iterator, it's literally saying copy each of these values to the standard output stream. And finally, because that output iterator has a delimiter of space also supplied, it's going to follow each value that gets output with a space automatically. So if we stop right there and take a look at this first line of output, you can see that indeed we were able to output the values of the integers vector one element at a time, separated by space characters automatically. So now you start to get a sense of the power of combining algorithms with containers and iterators. And one of the things I want to point out here is the fact that the algorithms have been separated from the containers for the most part, so that you can use them with multiple different types of containers. So this copy algorithm can not only work with the sequential containers, vectors, deques or decs, and lists, it can also work with the associative containers as well, because all of the containers support the begin and end iterator concepts. So that's a very powerful concept. Now, at line 23 and 24, we wanted to show you a couple of other functions that are part of the vector class, and in fact of the dec class as well. The front and back member functions give you the first and last elements in the container. So if I stop there, you can see that 1 is the first element and 6 is the last element. So sure enough, 1 and 6 get displayed. Now, at line 26, we're demonstrating the square brackets operator, saying that we want to replace the value at location 0 of the vector with the value 7, and that we want to, at line 27, demonstrate the @member function, which is similar to the square brackets operator, except that it does range checking to make sure that the index is within the range of indices supported by the underlying set of data. So integers.at2 says replace the current value at index number 2 within the vector with the value 10. So index 0 is going to become 7, so I'm replacing the 1 with a 7, and I'm replacing the 3 with a 10. I'm also going to insert a value into the integers vector, and here with the insert function, what we're saying is you give it an iterator that indicates the position where you wish to insert the item, and then you give it the value that you wish to insert. So by saying integers.begin +1, we're saying we want to skip the first element and then insert the value 22. And to demonstrate not only that the 7 and 10 were placed into the vector, but also that at the second position within the vector we inserted the value 22, we then use the copy algorithm once again, starting from the beginning of the integers vector, going up until but not including the end, which is again one past the end of the actual contents, and we're going to display those contents to the standard output stream using the iterator defined at line 18. So if we stop there and take a look at the output, we can see that the new contents of the vector are 7, 22, 2, 10, 4, 5, 6. Now remember, originally 22 was inserted after the fact. So item 0 was replaced with 7, item 2 was replaced with 10, then we inserted 22, which shifted the values of what were previously the second and third elements of the vector over 1 in the vector. So now the vector also contains the value 22 and is also one element longer than it was originally. Originally it only contained 6 values, and here you can clearly see that it now contains 7 values. Now, we'd said that we wanted to demonstrate catching an out-of-bounds exception, and basically we wanted to prove to you that the @member function really does throw an exception if in fact you access an index that's out of range. So here you can see that we are trying to access the index at position number 100, which does not exist in the vector. So when we attempt to do that, we get an exception of type out of range, and we're catching that here at line 40 and then just printing for you what the exception's message was. And if we stop there, you can see that the exception message was invalid vector of t subscript. So we gave it an invalid subscript inside of the @member function. Now, down at line 46, we start to demonstrate the erase member function, which is built into the vector class and many of the other containers as well. When you say to erase an element and you give it just one iterator, it says to erase the element at that position within the vector. So if I say integers.erase with integers.begin, that says get rid of the first element in the vector. And now here, notice we say nothing about the actual size of the vector, which has just decreased by 1. We just say go from whatever the current beginning is to 1 past the end and output those contents using the copy algorithm once again. So if I stop there, we can now see that after erasing the first element, which was 7, the vector starts with the value 22. The next thing we do is we show you erasing the entire range of elements, but with the starting and ending vector or iterator, notation. And this will erase everything from the first iterator up to but not including the position of the second one. And by doing that, we can then see that the vector is empty. So we're going to test that for you here, saying if the vector is indeed empty, output is, otherwise output is not. And if we stop there, we can see after erasing all elements, vector integers is empty. At line 56, we then demonstrate the insert function with a range of elements. And here we're saying that we want to start inserting them at the beginning position in the vector, and we want to insert values from the array called array, starting at the position array up to but not including the position array plus size, which again represents the full range of elements in the original array with the values 1 to 6. And to show you that we now have those values, we copy the entire integers vector out again, and you can see that the vector now contains the values from 1 through 6. And then finally, we demonstrate the clear function, which erases the entire contents of the vector without specifying any iterators. And to prove that the vector is empty once again, we use the integers.empty function call to determine whether or not we should display is or is not. And you can see that indeed, after clear, the vector is empty. So here we demonstrated several other member functions of class vector, and these member functions also work with the concept of a deck as well. We also showed you what I think is one of the most important and powerful concepts of STL programming, which is the ability to combine iterators, algorithms, and containers to do very powerful operations in single lines of code.